The second video lecture, and there's only two of them, deals with the principle called Le Chatelier's principle. Before we start, we're going to write down below this. It may not make sense now, but it's a shortcut that will help us answer almost every question out there. On the same side of the double arrows, the opposite thing will happen. On the opposite side of the double arrows, the same thing will happen. We can even write the shortcut as a shortcut and say same side, opposite, opposite side, same. So let's apply this to Le Chatelier's principle. Le Chatelier's principle states that there is a delicate balance which exists at equilibrium. If it is disturbed, the balance, by adding a stress, the system will shift to remove the stress, forming a new equilibrium position, which will change the concentration of the reactants and the products. There's four factors we're going to discuss. The first factor is concentration. As the concentration of a reactant increases, the equilibrium will shift to the right, producing more products, and vice versa. If we increase the concentration of a product, it will shift to the left and form more reactants. But our shortcut will answer almost every question out there. On the same side of the double arrows, the opposite thing will happen. On the opposite side of the double arrows, the same thing will happen. So if this increases, Cl minus on the same side decreases. It gets used up. If Cl minus increases, this on the opposite side increases. Opposite side, same thing. If this increases, then this on the opposite side, same thing happens, increases. We also have a secondary way of asking questions, and that's if we take something out. If we take something out, we're going to think ice machine. In an ice machine, if you take ice out, the ice machine will replace the ice that was taken out. If we take this out, the system will shift this way to replace what was taken out. Or if this goes down, this goes down. So it still applies to the shortcut. The second factor is temperature. An increase in temperature increases kinetic energy, which increases collisions, which increases both the forward and the reverse reaction. The reaction will shift in the direction of the endothermic reaction. But if you just remember the shortcut, everything will work out. So temperature increases because heat increases. So if you increase temperature, this on the same side decreases. If you increase temperature, this on the opposite side increases. If the temperature goes down, if you take this out, the system shifts to replace it. So this increases. But on the same side of the double arrows, the opposite happens. The third factor is pressure. Changes in pressure only affect gases. So you have to check out the equation and look at the phases. Pressure will not affect liquids, solids, or aqueous solutions. An increase in pressure shifts the equilibrium in the direction of the fewer moles of gas. If the moles of gas are equal, there is no change in equilibrium. So here, if there's no coefficient in front, it's understood to be 1. We have 4 moles of gas left of the double arrow. We have 2 moles to the right of the double arrow. I forgot to put examples in, so we'll copy these down. So what happens if you increase the pressure? Remember, if you increase the pressure, it shifts to the smaller side. So if we increase the pressure, it's going to shift to the right. What if we decrease the volume? Well, if you decrease the volume, it's the same thing as increasing the pressure. So if we increase the pressure, it shifts to the right. So CH4 will increase. If we increase the volume, that's the same thing as decreasing the pressure. So I tend to think in terms of what's going to happen if I increase the pressure, and then the opposite thing will happen. So this one's a little more confusing. If I increase the pressure, it shifts to the right. So if I decrease the pressure, it shifts to the left. So what will happen to CO? It will increase. And we're going to have plenty of practice with this in class. The fourth factor is a catalyst. A catalyst speeds up the forward and reverse reactions equally. Since the reverse is the exact opposite of the forward, catalysts do not affect the amount of reactants and products that form. They just decrease the amount of time it takes to reach equilibrium. So the addition of a catalyst or an inhibitor will not affect equilibrium. So if ever a catalyst is added, nothing happens. There is no shift. Well, that's it. And we only have 2 lectures for this unit, this chapter. So the rest of the time we're just going to work in class. Have a great night, and we'll see you soon.